Welcome back to the Art of Math. Today we're going to go over why trick 2 works. And if you're not sure what I'm referring to, that's mental math trick 2 from video number 7 in this series. So quick recap. Trick 2 involves two numbers where the tens digits are the same, such as 2 and 2, and 3 and 7 have to, the ones digits have to sum to 10. So instead of multiplying these numbers, the cool trick says that we can take the 2 and the 2 and add 1 to one of them. So do 2 times 1 more than 2, so that would be 3, and then take the 3 and multiply that by the 7. So the 2 times the 3 would be 6, and the 3 times the 7 would be 21. So basically, if you have something like this, you do 2 times 1 more than 2, so 2 times 3, boom, 6. 3 times 7, 21. So you can do this in your head in like a few seconds. Alright, so that's the trick, quick recap. Again, if this seems a little fast, go and review video number 7. Now, here's the proof. First, we might say, hey, okay, so these have to be the same, so that's A and A. By the way, these are not A times B. These are digits, so these little things underneath them represent the fact that these are digits. So we have the tens digit is A, the ones digit is B times AC. Not A times C, but AC. All right, that's fine, but notice we didn't take advantage of the fact that the 3 and the 7 add up to 10. So our first attempt is no good. So instead what we want to do is eliminate all of these variables and only have A's and B's. So we're going to keep these A's, so A, and this digit is B. So whatever this one is 10 minus that one. So the tricky thing here is we want to start, the hard part to start this proof is how do we even represent the problem? Like what are we trying to prove? So before we even engage, let's backtrack a little bit and see what exactly we're trying to show. We're trying to show if we have A, B as digits times A 10 minus B, that's going to be, what do we do here? We just added 1 to one of the tens digits and then multiply them. So A times A plus 1, so basically take these A, add 1 to one of them and multiply them, and then do B times 10 minus B to get the last 2 digits. Alright, so that's the trick, and we want to show that this is true. So what we're going to do is actually work on the left side and show that that's going to equal the right side. So here we go, AB times A 10 minus B. So our first step is to write this out in expanded notation. So we have A is the tens digit, so what does this A represent? It represents 10A. So if this is like a 7, this would be a 70. That's what we have this 10. So we have 10A plus B, that's just a ones digit, so it's a plus B, times, same times, A is still 10A, just like in the first example, and then 10 minus B stays 10 minus B. So here are two numbers written out. Now we're going to multiply them. It's going to be a little messy, but hang in there. So we're going to have 100A squared. So I'm basically doing the 10A times everything in here, so you're going to have 3 terms from that, and then another 3 from this B. So that's what you're going to get. And now these negative 10 plus 10ABs cancel, which is really neat because now we're not just going to rewrite this without these. We're going to do one more step. Notice these share a 100 and an A, so we're going to factor that out. And these share a B, so I'm going to factor that out. By the way, let me pause here because a lot of you might be thinking like, how do you know what to do? Like how do you know what to do next? That's why the hardest part in my opinion is setting up what we're trying to show. Because this gives me a little bit of a clue. We're trying to get something that's going to look like this. And notice here, we're kind of getting there, right? We have an A plus 1. All right, so we have this, and believe it or not, we're actually done. It doesn't look like that, but let me convince you that it is. So the 100 just means A times A plus 1, tack on 2 zeros in terms of digits, and plus whatever that is. Right? So these are like, this could be 1 digit, several digits. So the 0 is, you're going to add this to that. So whatever the 0 is just going to be replaced with whatever this turns out to be. So in fact, we were already done here, but I was just trying to show you that this in fact is that. So that's the proof of why trick 2 works. It's a little bit involved. The key idea is to represent your problem as digits with place values and then expand it. The hardest part, like I want to reiterate this because this is an important point, is not doing this part. This is tedious, but this is straightforward. The hardest part is representing the problem. Like, I had to think for a second, how would you even start this? We're like, oh, okay, these have to be the same. How do we encode that in the proof? Well, we'll give it the same variable. So that's an AA. How do we incorporate the fact that these have to sum to 10? Well, whatever this is, B, it's free to be whatever. The second one has to be 10 minus that. So that was a little challenging. And then I had to figure out, or we had to figure out, what the trick's gonna work out to be in terms of these general letters A and B. So it's not super hard, but it's a little tricky. So there you go. So that's why trick 2 works. And I just put this little silly box so we could put a little face in there. All right, I will see you guys in the next video.